Hey everybody, Joe here. Gonna check out a puzzle today by Shintaro Fushida-Hardy called Holographic Principle. I just did this not too long ago, but my recording decided not to record any of the audio, so I kind of already have worked through this, but I figured I would start over so my audio would come through. The rules are the digits 1 to 9 occur exactly once each in every row, column, and region. Regions cannot overlap, and each consists of 9 orthogonally connected cells. The region borders must be deduced. A digit in a cell with arrows gives the total number of cells in the same region as the arrow cell in all indicated directions combined. And the arrow cell includes itself in the count. Cells in different regions to the arrow cell immediately block vision and therefore prevent any cells further along the arrow's path in that direction from contributing to the arrow cell's count. So the first thing was that these two right here can only be a 1 or a 2, but if they were a 2, then they would be in the same region and there would be two 2's in the region. So they are a 1. And this one was also forced to be a 1 or a 2. Since we already have a 1 in the row, it is a 2. Which means that these three are of one color. And these two are a different color. And the corner, also any of these that are diagonal, you can see that their maximum value could only be 5. Let's use one that isn't. Well, we can use this. This will be part of either green or yellow, no matter which way it takes. So if it tries to be 5, then all of these will have to connect. In this example, we're using green. And you can see that that's already 9 cells. So this is 3, 4, 5. 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 This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Etc. Etc. 2, 3, 4, 5. 3, 4, 5. 2, 3, 4, 5. Okay. So we have a 2, 3, 4, 5 combo, as in the leftover cells are going to be from 6, 7, 8, or 9 in that column. And now the next thing was that this one has to be at least 3, and this one as well has to be at least 3. And then we could ask, can this cell here be a part of red? And the answer to that is no, because if it were, you could see that this would have to be at least a 3, 4, these would be a 3, 4, 5 combo. And then kind of, no matter how you did it, like if there were, 5, then it would have to do the stair step thing. And it would already be at 9. So this cannot be part of red. I will make that one yellow as well. So then we get a border started there. Yellow has to come on out. Okay, and the next thing was that this, we can see that it cannot be part of red, first off, because it would have to get all them, and that's way more than 9. And then the second thing is like, can it be part of that? And if they were the same, you could see that all of those cells would be 4, 5, 6, 7, or no, sorry, 5, 6, 7, 8, 9. That's 9 cells, and but these would both have to be 3. So this and this are in different regions, but this one must come down to at least there, but this one cannot be part of it, right? So this cell is going to be trapped like that, but that is also its minimum. So it must be 3. And then this one is going to be 4 because, as we looked earlier, if it were 5 and these were all, that would be 10 already. That would be 10 cells. So this is 4. And then red goes down to there at least. And it is also 1, 2, 3, 4, 5, 6, 7, 8. 8 cells. So it can get one more. 1, 2, 3, 4. So it could technically be that one if that was 5. And we did get a 5 over here. So these are going to make like an enclosed triangle up here. So we could speculate if it was green like that first off, and then count the remaining tiles. Basically there's already 8 in red, remember. This would be a complete green, and it would also be the maximum taken in this region from green. So cells left are 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there would be 2 cells left over. 1, 2, 3, 4, 5, 6, 7, 8. One, two, three, 4, 5, 6, 7, 8, 9. What did I do? Right, this one was not part of red. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this did have to be 4. I don't know why I colored that one. because I was thinking when I first saw it, I thought it needed to come out 3, but it is already 3 at the moment. So this was my speculation of that, and then I was counting leftovers: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there would be 2 left over, right? And at the moment, red is 7. So red's extra cells need to go up here to have this region up here where there's no spaces left, where there's no blank spaces left. So this one must be red, so it meets, and then its extra cell must be up here somewhere. And this must be green. This will be a new color, which we'll make yellow. Green is 9 cells, so we can draw its border. Okay, yellow must come out. Yellow must come to at least there, so it will get that one. Okay, and red also goes down no further. So when yellow gets full to 9, 4, 5, 6, 7, 8, 9, then you'll see there's exactly enough cells for red and yellow to complete up there. And now oh yeah, that was yellow, because that was its minimum. And then if we start thinking of Sudoku, we can see that the ones are blocking those 2 rows, right? And yellow and red both still need a 1. So that means this must be yellow to get its 1, and then red's 1 must be there. And then we have one of these is yellow, one of them is red. Eventually to be seen. This can no longer be 5, so it is therefore 3. We can also see that there's going to be a 2, a 4, and a 5 somewhere in this row, but for yellow. So there would be a 2, 4, and 5 somewhere here in yellow. But red also needs a 5, and it must go here, therefore. This will now be a 2. It will get that, but it will get no more. So this is basically a different color, is what I'm saying from that. I can make that pink. If this here was part of yellow, then it would have to be the 5 because it would already be a 2, right? So it would be 1, 2, 3, 4, 5. And then you can see, as soon as we connect them all, we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this must be a 1, which also means that it cannot, excuse me, cannot be part of yellow. Because if it was a different color and it was 5, then there would be something, that there would not be enough spaces down here for another region. So we can make this one, we'll make green. And it also means that this is not green, but, or well, okay, yellow, we don't know if it takes this one, but even if it did, it would still have to come out this way. So green must in turn also come out, and that's where we are there for now. So these down here are going to be at least 5. On the corner one though, we can ask, can that be 9? And it would be either like, or well, no, I guess first off, we could ask, could it be green? Or could this one be green, rather? And if this was green, then it would have to include these two as well, right? So if this one was green, these two would also have to be green. And you can see with this being 5, and this being, well, the minimum this one can be is 5, the minimum this one would be is 6. So it would look something like that. And this is 5, 6, 7, 8, 9, 10. So this one cannot be green. It cannot be yellow because green would be trapped. It cannot be pink because, again, green and yellow would not have enough room. So it is a different color from anything we have on there so far. And we will use red for that one. And this is now at least 3. So we get that. Alright, and then the same thing would be for, we could ask the same thing again for the corner. Say, is this green? So it would be 5, so the minimum this could be is 6. So it'd be like that. So it'd be 6, 7, 8, 9, 10. So it cannot be, it can't be anything new. So it must be part of red. We have 1, 2, 3, 4, 5, 6, 7, 8 regions so far. And we know, oh, and if this was 9 now, we can see that it just won't work. And then we could also do like this. That would not work either because both these would be 9 on both ends. So this cannot be 9. And therefore, now we know that nothing else that is currently, no colors that are currently here will reach. So this is our last region, and we will make that blue, and this corner one is at least 5. And if it were to be part of red, it would have to be at least there. That would be 10, and so it must be part of green. It cannot be part of yellow, cannot be part of pink. It would trap too much in, and we cannot have a new color, nor can we reach blue. So it is part of green. It comes over to at least there. It is currently at 8 cells. Red must continue its journey outward. We get a 1 here from that. We get to continue our colors for blue. We can say that is a maximum of 3. So 4, 5, 6. It must be a minimum of that. And therefore, this must be a minimum of that. Okay. And no other cell can reach there, so it must be pink. If this was part of blue, it would, it couldn't be 1, so it would have to go up at least 1, making it at least 3. So we are at 7 there. So far this corner one would be at 2, 3, 4, 5. It would need to get 1 more. It could get there. 1, 2, 3, 4, 5, 6, 7, 8. So that would look okay at the moment if red was to turn up and do something that way. Alternatively, what else was 2s? 2s are being forced down there for green. We know there's 2s on this row. We see that one. That's the only place left. 4s would be somewhere in there. 6, 7, 8. This cannot be 9. Maximum could be 8. This one, if this one was yellow, that would be yellow. So far it's at 4, 5, 6, 7, 8. so it gets one more. This would have to be two, and then yellow would get just one more. But it would also make all of these blue, therefore all of those blue. This would be two, so this would have to be three. It would have to go there. It would have to get at least one more cell. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this cannot be part of yellow, therefore it must be part of blue, as if it were, because the only other color it could reach would be pink, right? And it would just make 3, 4, 5, 6, 7, 8, 9. It would just make 9, but then yellow, 1, 2, 3, 4, 5, 6, 7, 8, would only have 8 cells over here. So that had to be part of blue. Now it goes down to at least there, and then 1, 2, 3, 4, 5, 6, 7. So since this can only have 2 more cells, right, because we have these 2 here, needing to not both be 2, right? So once we put 2 cells on here, we cannot make either one of them 4, right? Because we'll end up with 10. So no matter which angle we want to try it with, we just cannot make either one of them 4. So it's going to be a 2-3 combo. This is going to be a 4. Yellow is going to come down to here and forced up into there. This is also at 8 now. 3, 4, 5, 6, 7. Yep. And also, if this corner one was to take this, again, it would have to come up, and that is already 9 cells, and it would break these 2, as in they would both need to be 2, because that is all they see. So this one is not part of light blue, and we can see that 3, 4, 5, 6, 7, 8, 9, 10, it cannot be part of pink, therefore it must be part of red. Red must be 8. This one must be 2, and this is red's last cell. This is now unable to be anything except for 6. It does force it up into that empty nook there. And then this is going to be yellow, because we know that our last cell is going to be one of these to make these be a 2-3 pair. This is 6. It will also give us a 6 here, because it cannot go on anywhere else in red, as it is all in that same row. I think yellow is done. 3, 4, 5, 6, 7, 8, 9. It is. We can draw it in. And also, we can, this is 8, I believe. Yes. So we can ask, can anything reach this? And the only thing that can is pink. So pink must go toward pink. Yellow obviously cannot poke into here, or else pink would not connect to itself. So it will do something like that, and then we can also think here. Of course pink couldn't go there because then blue would go here and it would be all broken. So it must go like that in order to work, and we get our little region there for blue, and this is now 3, this is now 2, and this is a 7, 8, and 9. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 1 in light blue, there's already 2 in those 2 columns being forced into there. Also the 4 and 5 are being wedged into there as a pair. So there's a 3 left to place. It cannot go here, so it will go somewhere in this column of yellow, and there is a 7, 8, and 9 to go with it. We already have a 9 in yellow, so 9 goes there, and a 7, so this is 3 because 7, 8 are already on its row, and then a 7, 8 will be a pair there. There must be a 1 somewhere in this column. If it goes here, then obviously that has to be pink. Green already has this. There's also there's going to be, so we got 4s here, we got 4s here. There must be a 4 here with the 2. We have a 3, 3, 6, 8 left. So this one will be 6, 8. This will be 3, 6, 8. That's how that will look. Also, we know the 2 is on this row. There must be a 2 in yellow. It will be here. We have this one blocking here. So now we get the 2 there. This is now a 4. This is not a complete pencil mark here yet, because I need to sort this out between red and yellow. I need to do more Sudoku for that. I do believe this is going to be a 5, 6. this cannot... Oh, this has to be 5. It could not be anything else. So, that is where that ends. This is pink. We still have one more green somewhere. At 4, 5, 6, 7, 8, 9. Pink is done though, it looks like. Yep. So now that pink is done, we see that yellow tucks into that corner. Green cannot reach this, but we're not sure about those. One, 2, 3, 4, 5, 6, 7. And we know that it gets that one. Because it could not get that and that. Okay. So one goes in here for pink. Are ones done? No, ones are not quite done. Ones. One will go there for yellow. There for pink. Do you think we have all the arrows done? We'll need a 2 in pink. This is a 6, 7, or 8. A 2 in green. Two could go there still. Yeah. Okay. I'm not ready for that. have all my ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, yes. Twos. 1, 2, 3, 4, 5, 6. 7, 8. Be 2 here. Threes. 3 here. There will be a 3 in one of these for green, which puts 3 in one of these for pink. Cannot be there because of that one. So 3 is there for pink. 3 is going to be there then for green. That's going to make that one yellow. It's going to finish off those. That is now no longer 3. 3 must go in here somewhere though, and it goes right there. This is 6, 7, 9. This is 5, 6, 7, 8, 9. Four is now in this row. What else is in this row? It's going to be a 2. 6 will be in one of these. An 8 will be in one of these, not the third one. And these could, I'll just go ahead and fully mark this one. That'll be 7, 9. These get a 2, 4, 8 though. 2, 4, 8. That not being a 2, that not an 8, another 2. Alright, so this is not a 2, this is. Three, 4. 5. No. 7 will be in one of those. I guess a 7 could go down here as well. A 7 goes in one of those. Not ready for that yet, I don't think. Oh, a 7, 8, 9. 7, 8, 9 combo there. So this is a 5 or 6 only. Didn't help much. Okay, look in the right spot. Where is it? Where is the right spot? 1, 2, 3, 4. 4. 4 cannot go here. Got 3 choices. 5. 6. 7. 8. 9. Okay. Need to find that one that was hiding. Forget where it was. Let's just recheck. 2s right quickly. Just here and here, I think. 3s. 3s. Maybe one of these. And one of those. 4s. Oh, we only have 3 4s. Yellow. Oh, wait, never mind. Four cannot go here. Alright. So there must be a 4 in this column. And the 4 cannot go here because we know it goes on this section here because of the 4 blocking it elsewhere from green. So there would be no 4 in this column if it were not here. So that is 4, that is 3. And this is now 3. That should be the last 3. One, 2, 3, 4, 5, 6. This is a 7 or 8.
quite a lot. Oh, this is not an 8. This is a 1, 2, 3, 4, 5, 6. Yeah, this is only 7. This is not an 8 either. A 7 now goes here with 6, so no 9. This will be 2, 4, 8, 9. This has 5, 7, 9 left. This is a 6-8 combo, making that a 5. Making this a 6. Six now goes here. Six will be in one of these. This is no longer a 7. Four. Oh. 4 kid goes there. This was an 8. An 8 has to go here. It's looking up this way, looking over this way. Red still needs an 8. Must go there. This is now a 4, 9. Now 6s. There'll be a 6 in one of these, and there'll be a 6 in one of these. It's gonna be 5, 7, or 9. Oh, no. 5 or 7 only. Is this a 4 or 5 actual? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that is only 4 or 5. This is 2, 4, 5. This can be 7. That is it. This is 2, 4, 5, 7. What is it? Five, 7, 9. So that will be red's 9. It'll be red's 5, and it'll be red's 6. 1, 2, 3, 4, 5, 6. So it only needs a 7. A 7 could still be at the top, though. This looks to be 7 or 9. And this will also be 6, 7, or 9. This is for 4, 5, 6, 9. 8 only here. Oh, this is a 9. That's been sitting there forever. This is a 6, 7 combo. This was marked as 7, 9. Can't be a 7 when there's one right there in the same column. Alright, and then this... Well, we already have it, but what I was going to say was I think I found it earlier, the last time I did this, is that I sorted out that 7s could go here, and 7s had to go here, so these two could not be 7, so they made an 8, 9 combo, and that had to be 7. I think is how I stumbled upon that last time. So, what other magic did I do? Any? I don't know. So one of these is a 7. One of these, yes. One of these must be a 7. This, therefore, is not a 7. This is now the only spot for a 7. this is a 4-5 only, which gives a 4-5 in the column, which makes this a 2 and makes this a 9. Makes that a 4, that a 2, that a 5, that a 4. Gonna get a lot. Whoops. Gooped. That must not have been a 1, 2, 3, 4, 5. Oh, this is a 8. That is the only spot for an 8 to go in there. My bad on that. This is now a 5. This is now a 9. This is a 4. And I think that should about do it. And thank you for watching. Hope you enjoyed. Play yourself in the link below. And yeah, nice puzzle there by Shintaro Fushida-Hardy called Holographic Principle. All we have left to do here is figure out where this is yellow for the 5. This will have to be red for the 7. And let's not forget to draw our borders. That should do it now. Thanks for watching. Have a great day. Bye bye.